Here we have one more problem related to the relative motion. So problem number 74. A ship sets a sail from Rotterdam, heading due north at 7 meters per second relative to the water. The local ocean current is 1.5 meter per second in direction 40 degree north of east. So what is the velocity of the ship relative to the earth? Okay, now let's draw a picture. So we know that, let's first draw the coordinate systems. This is our north, this is our east, west, okay, sorry, south and west. Also, let's define that this will be our I vector, this will be our j vector, okay? This is our y, this is our x, okay? Okay, let's see what's happening here. The ship sets a sail from Rotterdam heading to the north at 7. Okay, so basically the ship is moving to the north. So velocity of the ship relative to the water, okay, which is equal to 7 meters per second. Now, then we have a local ocean. Current is 1.5 meter per second in direction northeast. So that means we have here a water which is directed to the northeast, okay, that has a velocity which we call it the direction velocity of the water relative to the ground, okay. This one has the magnitude which is equal to 1.5 meter per second. Now the angle between them, the angle is 40 degree. Now what is the velocity of the ship relative to the earth? That means we have to find, if its station is here, what is the velocity of the ship relative to the ground. That's what we have to find, okay. Now as you can see here, we have two velocities. The velocity of the water relative to the ground can be resolved into two components, correct? So this one will be y component or j component, which we can say that velocity of the water relative to the ground multiplied to the sine 40 degree. What about that one? This one is equal to velocity of the water relative to the ground will be velocity of the ground multiplied to the cos 40 degree. Now you have to keep in mind this is this is x component and this is our y component, okay. So that means we can see that if you look at the y component, okay, if you want to find the y component, then we can see that we have one velocity, which is velocity of the ship relative to the water, and plus we have velocity of the water relative to the ground, okay, which is equal to 1.5 multiplied to the sine 40 degree. So that means since they're pointing to the same direction, you can just add these two vectors. So you can say that for the y component, velocity of the ship relative to the ground in the y component is equal velocity of the ship relative to the water plus velocity of the water relative to the ground. Okay, this is in the y component, so that means we have 7 meter per second plus 1.5 times sine 40 degree. So that means finally we should get that our y component will be equal to 7.96. okay, for now we can just call it probably j vector. What about x component? What about x component? Now for the x component, let's say that for the x component, do we have, okay, for the x component we can say that velocity of the ship relative to the ground in the x component is equal velocity of the ship relative to the water plus velocity of the water relative to the ground. Okay, it all has to be in x component. So that means velocity of the ship relative to the water in x component is 0. Okay, but we only have velocity of the water relative to the ground, which is 1.5 multiplied to cos 40 degree, which should give you, after the calculation, 1.15 I vector. Okay, so now we got that our velocity of the ship relative to the ground is given in terms of 1.15 I vector plus 7.96 j vector. Obviously you can find the magnitude of it, 1.15 squared plus 7.96 squared. Now if you find it, then you will see that your answer is equal to 8.04, okay, meter per second. What about the angle? Now the angle is basically this one, okay, let's call it theta. So theta can be found by using the inverse tangent, which is theta is equal inverse tangent divided by the 7.96 divided by 1.15. So after doing the calculation, you can find that your angle is, let me find it, inverse tangent 7.96 divided 1.15. It will give you 81 degrees. This is how you solve such a problem.